Let's make a couple of crankshaft bearing holders. Hey YouTube, what's going on? I'm Greg. Welcome back to my machine shop. Today we're going to be making some bearing holders on the lathe. This bearing will be mounted right about here with the bearing holder, and the crankshaft, of course, will go through. Today I'm going to try to give you a close-up view of the DRO and show you how I use that on the lathe. I've seen a lot of videos on how the DRO is used on the mill, but not so much on the lathe. Okay, let's take a real quick look at the print and get started. So we have two bearing holders to make, the rear bearing holder and the front bearing holder. They're almost identical. There's only two dimensions that are different. So we're going to go ahead and just start with the rear bearing holder. There's two critical dimensions on our bearing holder. One is this inside recess where the bearing slips into. We want a nice snug fit between it and the bearing. And then this outer surface here of this lip that slides into our crankshaft bore. We want that also to be a very tight fit. On the outside there's another lip that's not very critical. So I have some 1.75 inch stock and some 2-inch round stock. The outside is 1.75 inches. I think I'm going to save that 2-inch for later and use my 1.75 inch stock. This is not a critical dimension. That's a little bit undersized to be cleaned up. That's fine. So I think our strategy is going to be to face this outside face here and then make this internal feature and the outside feature test fitting both with the bearing and with the crankcase. Then parting this off, turning it around in the lathe, clamping on this inside feature and finishing the outside. Then we'll take the part out, load it in the mill, and drill these 6 holes. All right, let's jump on the lathe. I use a bearing mounted in the tool holder to rough center the workpiece in the 3-jaw chuck. Making of the bearing holder starts with a set of very classic lathe operations. Then we face it off, turn the outside to dimension, spot drill. We want to end up with a 1/2 inch hole for the crankshaft. We drill with increasingly larger drill bits to just undersize, and then ream to the final 1/2 inch. So now the fun begins. We're going to rough out the bearing pocket. The final diameter is 1 1/8 of an inch. So for the roughing, we're going to target 1 inch in diameter. The depth is 0.315, so we're going to target less than 0.3. Let's take a look at the DRO. The top number is the position of the cross slide measuring diameter. So we're going to set that to 1 inch. Then the bottom number is the position of the carriage. We're going to start at 0 and proceed in to about 0.28. Since this is a finishing calibration cut, we'll use the fine power feed on both the carriage and then cross slide motions. I make one more fine cut on our bore, this time moving the carriage straight out without disrupting the cross slide position. At this point, we use our micrometer to take an accurate measurement of the internal bore and set our cross slide DRO to this value. We are now calibrated. $2933. 294. So we're within 1,000th. Now we carefully sneak up onto 1.25 on the diameter of our bore. We take smaller cuts, continue to measure the bore, and test fit the bearing as we approach our final dimension. And once we hit the bearing pocket depth of 0.3125, we advance the cross slide to finish off the back of the pocket. Then the final test fit of the bearing. I don't want to push it all the way in. I want to make sure I can get it back out of there. We have one last feature we need to make inside the bearing pocket. It's an additional 10,000th recess to clear the bearing inner race. 3125, 3125, that's 0. Okay. Now we machine the outside of the bearing holder, the lip that'll fit in the crankshaft bore in our crankcase. We follow the same steps as we did before, roughing out the material and making a fine pass, measuring the actual size, entering that into the DRO to calibrate it, continue machining, sneak up on the final dimension, test fitting with the crankcase, and then repeat until we're happy with the fit of the crankcase on the bearing holder. And then I parted it off. However, I parted it off prematurely. As I mentioned earlier in the video, I should have finished off the features on the back side so they remain concentric with the crankshaft hole. I'm afraid if I get it in there, I'm not going to be able to get it back out. There we go. Nice tight fit. However, I made a mistake here. Darn it. So I cut these off. I finished the features on this side. My plan was to turn it over, machine this here, but I should have machined this spigot while it was still in the lathe in this setup, because I want this feature here on both of these to be concentric with the bore. Now I have to mount this in the lathe backwards, take an indicator and recenter this thing to make sure that this front feature is concentric with this bore. Darn, not the most efficient way to do it, but I think we can recover. I went ahead and finished machining the features on the back side. Pretty much a repeat of the features on the front side, except I did center the part using a dial indicator to make sure I had my concentricity. Here I've put the part into the mill and using the bolt center feature, going to spot drill and drill the 6 holes. I need to be careful I don't hit my parallels. So that almost finishes up our crankshaft bearing holders. I say almost because I drilled this hole undersized. It's supposed to be a 140 clearance hole for a 632 screw. I drilled it to 0.110 because I want to use this as a drill guide. So I'll put this in here, position it, and then drill the holes using this as a guide. While I was at it, I also made the camshaft bearing holder. And I went ahead and pressed it into our front timing case plate. It's right here. The process is the same as the crankshaft bearing holder, so I went ahead and completed that. What that allows me to do now is I can put this onto here, and that will align the timing case rear plate, and I can use it as a drill guide to drill these other 1, 2, 3, 4 holes. Well, let's call that a wrap. We finished our crankshaft bearing holders and one of the camshaft bearing holders as a bonus. So, I'm Greg. Thanks for visiting me in my machine shop. Until next time, take care.